Good afternoon, students. Am I audible?
Yes, ma'am.
Okay. We will wait for 2 minutes as the number of participants are only 10. So we will wait for 2-3 minutes and then we will start with the lecture. Okay, still the participants are very less. 59 participants have joined. Okay, then also we will start with the lecture now. So just tell me whether the screen is visible. Yes, whether the screen is visible to you.
Yes, ma'am.
Yes, ma'am.
Okay. Okay. So in the previous lecture, actually we have conducted the guest lecture for the chapter number 6. Whether all the concepts of chapter number 6 are clear to you? Yes. The guest lecture, he has taken the curves chapter, curve representation, the type of curves, curve interpolation, the two types of curves, Bezier and B-spline curve and their properties, and fractals. So this much part it's covered in the guest lecture. So whether all of you have understood that part? Yes. What about boys? Yes, students. Reply either it's say yes or no, anything. Some portion you have understood, some portion you want me to repeat, or anything from chapter number 6.
Ma'am, explain that Bezier curve.
Bezier curve. Anything else?
No, ma'am.
Okay. So Bezier curve, as it is for practical also, we are going to conduct the practical on Bezier curve, how to trace that curve, and what is the expression for the curve, and how to generate the Bezier curve. What are the properties that we are going to learn for practical use also, because in practical also we are going to implement that Bezier. So I will cover that Bezier part. Anything else? Okay, so you can go through your syllabus again, and if you find anything that you are not understanding, I have already uploaded that lecture, guest lecture also in your channel. So you can go through it, and if anything you are not able to understand, then just inform me. I can arrange the repetition of that particular syllabus. So I will explain whatever the things are not understood by you. Okay, so let us concentrate now on this chapter, visible lines and visible surfaces. So for that, we have seen what is meaning of visible lines and surfaces. So the portion which is visible with respect to the viewer is only kept on the screen for display purpose. The backside portion or the hidden portion is getting removed, and that is mainly useful in case of memory management, and the amount of memory required to store the visible surfaces will be less, because we are removing the portion which is hidden with respect to the viewer, right? And to achieve this, we can have 5 algorithms we have studied. In that, first was the backface removal algorithm. There we are concentrating on the normal vector. So we are concentrating the viewing direction and normal vector. So if the angle between the viewing direction and normal vector is less than 90, then that surface is considered as hidden. And if the angle between the viewer and the normal vector of the surface is greater than 90, then it is considered as a visible portion. So that we have already covered backface removal method. Then the second algorithm we have studied was Z buffer algorithm. In Z buffer algorithm, 2 buffers we are maintaining. One is to store the Z coordinate of all the points of the objects, and second is the intensity with respect to the specific point. So the point that we are going to store, the Z value of that is getting stored in one buffer, and its intensity value is getting stored in the other buffer. And then we are comparing the Z values, and whichever is closer to the user, that means less Z value is there, that is considered for the display. And the Z value which is greater, that is considered as the background intensity. So accordingly, we are getting the output for the Z buffer algorithm. So here the main thing was in Z buffer was the comparison is comparison between each point of the object is very time consuming. So if we are going to use the hardware implementation of that, then obviously the time required will be getting reduced. So that we have already discussed about Z buffer. Then we have seen the Penter's algorithm. So it is working exactly opposite as that of Z buffer. It focuses on the background pixels first, having the maximum Z value. So it works as that of Penter. So Penter used to draw the objects which are at the far. He used to draw the objects first, which are at the far. So same way, the Z coordinate is sorted in terms of maximum Z value, and accordingly the steps are carried out, whether the what it is the Z value, and accordingly you are having the some tests for overlapping surfaces. So that was the Penter's algorithm we have already discussed. It has total of 5 tests. First, type 0 or the test 0 is for non-overlapping surfaces. Test 1 is for overlapping, but not in case of XY direction. Then the third is overlapping in Z as well as X direction. Then we are calculating the overlap surface, and which is in the front and which is at the back. So we are calculating those, and at the end we are going to have the overlapping surfaces. If we cannot resolve those, then we are reordering the surfaces. So that is the Penter's algorithm we have studied. Then we had this Warnock algorithm also. So the concept behind Warnock algorithm is it uses the method of divide and conquer. So the whole picture is divided into 4 subparts at a time. So if the if the Warnock algorithm, or it is also called as area subdivision method, area subdivision algorithm. So it uses the method of dividing the screen into 4 parts until and unless you get the simplest part, that is either the trivial cases are handled. So you can have the subdivision of the screen until you receive the trivial cases. Okay, and if non-trivial cases are there, then you are going to divide it into 4 sub windows again. So this process of recursive subdivision is carried out in the Warnock algorithm. This algorithm is having 4 type of tests between the surfaces, that is the surface and the window. So if the surface is totally inside, then we are going to call this test as inside surface. Then outside surface, that means the surrounding window and the surface is completely outside. Then the overlapping is nothing but some portion is inside and some portion is outside. And you are having the total rejection, that is nothing but disjoint, where the object and surfaces, they are not having anything common. So such things are called as disjoint. So these 4 cases are considered, and we are going to divide the screen into 4 till you get either content surface or the inside or outside surface. So that is continuous subdivision of the screen is carried out. So we have seen this diagram also in the previous lecture, where the total surface is inside, the total surface is outside the window. Then content is this condition, overlapping is this, some portion is inside, some is outside, and this is outside. So we have these 4 cases. Then we have seen this also, quad tree and octree structure. Quad tree, when you have a 2-dimensional object, then we are going to divide it into 4 parts only. When you are having a 2-dimensional plane, like if any image is there and you are going to observe with respect to a 2-dimensional entity only along x and y direction. So if you are having this example, a plane of paper with 2 objects, like 2 rectangles are overlapping each other. So if this is the example, then it is a 2-dimensional entity, and in that case we are simply subdividing the screen into 4 equal parts until you get the simplified portion or simplified picture out of earlier 4 cases. So go on subdividing the each sub window, and every time you are going to generate a quad. So first subdivision is nothing but you are going to divide the screen into 4 parts. So it is called as 1A, 1B, 1C, 1D. So we have seen this example earlier also, 1A, 1B, 1C, and 1D. So we are getting 4 parts at a time. Then again, this window is divided into 4 subparts again. So I'm going to have this 4 equal subparts. So again, the smaller version is called as 2A, 2B, 2C, and 2D. Okay, so your total screen is acting as the root of the tree. Total screen coordinates, I will say screen coordinates, SC, is acting as the root, and it is subdivided into 4 parts every time. So that it will have first part as 1A, then 1B, then 1C, and 1D. Again, 1A is subdivided into 4 parts again, with 2A, 2B, 2C, and 2D. And this process is continued. Continued till which point? See here now, this 2A, 2B, and 2C. These three portions are not having any picture element in those areas. So here 2A is one area, 2B is second area, 2C is third area, in which this is your picture, which is represented two rectangles which are overlapped. So this is your picture. And out of that picture, these three portions, this 2A, 2B, and 2C, they don't have any picture element in it. So what we can do, we will stop subdividing this and we will assign the background color to them. So these three will be stopped. After we are going to give background color to them because picture element is not present in these three areas. It has the background color. Okay, this portion is having the background color. So consider this is our background color. So we are going to give the background color to this area. Okay, so what test we have carried out? We are carrying out the picture and the area, whether they are contained, whether they are overlapping, whether they are disjoint. So here for this 2A, 2B, 2C, we have found that the picture and these three areas are disjoint. They don't have connection between them. And that's why the step we have taken is we are coloring them with background color. Now only 2D is getting subdivided further. So 2D is containing only the portion of the picture and that's why it is getting subdivided. So see here, I am going to subdivide it into 4 parts again. Into 4 parts. So it is subdivided as, yes, is there any difficulty? So 2D portion is subdivided into 4 parts again. So every time quad means what? Every time 4 parts are getting generated and that's why this name is given as quad tree structure. So we are going to have this tree-like structure and each node is having 4 children. Each node is having 4 branches coming out, that is 4 children, and this structure is called as quad tree structure. So 2D is divided as again 3A, 3B, 3C, and 3D. Now if I observe this 3A portion, this one, so again it do not contain any picture element in it, right? Because this portion is still disjoint from the picture portion. So these 3 blocks are having picture in it, but this 3A is not having any picture element. So again, what I can do is I can assign the background color for this 3A portion and further subdivision is stopped. And 3B, 3C, 3D, I will be concentrating whether it is following any of the earlier 4 categories, whether the whole window is inside the object or the whole object is inside the window, or they are disjoint or they are overlapping. So what you are observing here, this whole area is inside the object now. You can observe this. This is 3A, 3B. So what happens with this 3B? This whole portion is inside the object. Object is this vertical rectangle. So now it will concentrate on the color of that rectangle. So this 3B, as it is totally contained in the object, the portion, that is this area of this window, that is 3B, is totally inside the object, totally contained in the object. That's why this portion will be given as picture color of this vertical rectangle. So suppose this vertical rectangle is having color green. It is not visible. Okay, this is having color white. So vertical rectangle is having white color. So what is my job? So my job is I will assign this 3B as white color. Then this is your 3B, 3C also is of white color. And now what happens with 3D? 3D is the portion where it is composed of the backside object, backside rectangle. Maybe it is of black color, let us assume. So this backside rectangle is of black color. So now for this smaller portion, which is 3D, now 3D is totally contained in the background rectangle, and that's why this 3D will be assigned the color black. Okay, and that is how the further subdivision is stopped. Then I will be concentrating on 1B portion, and this process is repeated. So what we are going to do is we are going to divide the screen, and at the end we are going to conquer them. So we are going to conquer these elements, that is 2A, 2B, 2C, 3A. They will be of background color. So I will conquer them and I will get a portion like this. I will get a portion like this. So this portion which is conquering will have the background color. Then I will conquer 3B, 3C together, and which will be of white color. So 3B and 3C I will join together and they will be of white color. And then the 3D will be of black color. So in the same manner, you are going to apply this method on all the sub areas. Okay, so this is how your Warnock algorithm works. Now this is true for a two-dimensional object, because a plane of paper we have considered a 2D object. But when it comes to 3D object, then the 3D cube is subdivided into 8 portions. You can observe here how the subdivision is done. So 4 and backside 4. So total 0, 1, 2, 3, 4, 5, 6, and 7. So total 8 partitions are carried out. And in that case, this whole screen coordinate is getting divided. This is your screen coordinate, which is root of the tree. And it is divided into 8 subparts. And each again is divided into 8. Right? Because this is your 3D entity. So this type of structure is called as octtree, because 8 parts are getting generated, 8 branches are getting generated. In the quad tree, we are generating only 4 branches. Okay, so this comes for MCQ type of questions, like in quad tree 4 branches, in octtree 8 branches, and that is, or you can have the question like in 3D objects, Warnock algorithm is applied and you are going to generate which of the tree structure. Then options are quad tree, octtree, like that. Okay, so for 3D you are going to generate the octtree, and for 2D you are going to generate the quad tree structure. Okay, so that is about the quad tree structure. So this was the Warnock algorithm. So is there any difficulty in this? Already we have covered some portion out of this. I have revised this quad and octree because last time we were in hurry for this quad tree and octree. Okay. So is there any difficulty in this bit? Warnock algorithm, all of you are clear with?
Yes, ma'am.
Yes, ma'am.
Okay. So let us move towards the last bit of the chapter, and that is anti-aliasing and half toning. Okay. So anti-aliasing. Anti-aliasing means what? The see, in computer graphics, you are having the raster scan graphics. Raster scan म्हणजे काय? Pixel by pixel, we are plotting the picture, right? Okay. So pixel by pixel, we are plotting the picture. So whenever I want to draw any line, what will happen? Let us see. So I am going to draw a line. So this is the first pixel. Then the second pixel if the line is slanted. Okay. This is your second pixel. This is your third pixel. This is your fourth pixel. This is your fifth pixel. Now these pixels are very small. Right? These pixels are very small. Then also you are able to view this staircase effect. म्हणजे स्ट्रेट लाईन जी यायला हवी होती अशी, त्याच्याऐवजी तुम्हाला आउटपुट कसं मिळतंय? थोडीशी zigzag line. Okay, and this particular effect is called as Jaggis, or it is also called as staircase effect, or it is also called as aliasing. Okay, so this is called as aliasing. So anti-aliasing means what? We are going to remove such effects from the picture. हा जो staircase effect आहे किंवा त्याला Jaggis म्हणतात, तर if we are going to remove these Jaggis or staircase effect from our picture, then it is considered as anti-aliasing methods. Okay, so let us see the definition. Anti-aliasing is a technique used in computer graphics to remove the aliasing effect. So this effect. The aliasing effect is appearance of jagged edges. Jagged edges म्हणजे काय? तर zigzag edges. Okay, so the aliasing effect is appearance of jagged edges or Jaggis in rasterized image. So you have to keep in mind this happens only in case of rasterized image. कारण आपण pixel by pixel plot करतो. जर random scan image असेल random, then we are using the vector to plot it. मग आपण काय करतोय? पिक्सेल बाय पिक्सेल प्लॉट नाही करत, वेक्टर बाय वेक्टर प्लॉट करतो. अँड इन दॅट केस these aliasing effects are very less. त्या केसमध्ये काय होतं? Aliasing effects are almost null. So this is the drawback. Aliasing effect is the drawback of rasterized image. So this is one of the favorite question of the examiner for MCQs. That is, in rasterized image, you are able to get this aliasing effect or Jaggis. Rasterized image, that is an image rendered using the pixels, right? So we are drawing pixel by pixel on the output screen, and that is called as rasterized image. The problem of jagged edges technically occurs due to distortion of the image when scan conversion is done with sampling at low frequency. So why it is happening? Because I am going to scan this whole line. I'm going to scan this whole line, which is called as scan line. So our method of rasterization is nothing but we are scanning from left to right. Once we reach to the rightmost pixel, we will start scanning from the next line left to right, and this process is repeated. So as I am reaching here and then scanning the line again, so it will have the low frequency in the scanning speed. That is nothing but whenever I am performing this scan conversion or scan line method I'm using that scan line method, then it uses very low frequency, and due to that these staircase effect gets generated. So that is called as sampling frequency. So we are going to sample with a low frequency. If it is done with the low frequency, then it is called as undersampling. So we can say that this aliasing effect is due to low frequency sampling, or which is also called as undersampling. Okay, so aliasing occurs when real world object which comprise of smooth continuous curves are rasterized using pixels. Actually आपण consider करतोय की ही लाईन आहे जी 00 to 100 आहे किंवा 00 to 100,50 आहे. Okay, so this is the line. ही line actually कशी आहे तुमची? Whenever I want to draw a line from 00 to 100,50, it is a straight line. मी जर स्केल आणि पेन्सिल घेऊन जर ही लाईन ड्रॉ केली तर तुम्हाला हे जॅग्ड एजेस मिळतात का? नाही मिळत. तुम्हाला 00 to 100,50 एक स्ट्रेट लाईन मिळते, बरोबर. पण इथे का मिळतं? कारण इथे आपण पिक्सेल बाय पिक्सेल प्लॉट करतोय. तिथे आपण काय करतो? At a stretch like a vector, we are drawing the line with scale. So here we are plotting pixel by pixel, and that too completing one horizontal line at a time. जेव्हा एक हॉरिझॉन्टल लाईन कंप्लीट करते मी, त्याच्यानंतर नेक्स्ट लाईनला येते आणि सेकंड लाईन प्लॉट करायला चालू करते. ड्यू टू दिस इफेक्ट वी आर गेटिंग द स्टेअरकेस जनरेटेड और दिस जॅग इज जनरेटेड. Okay, so aliasing occurs. Meaning of this line is aliasing occurs when real world objects म्हणजे line ही 00 to 140 ही line 150 काय असेल ती. This line which is comprised of smooth and continuous curves. ती actually smooth line असते किंवा smooth curve असतं. But when we are rasterizing using pixels, then it gets jaggies into that or aliasing into that. Causes of anti-aliasing is undersampling. So we have already known that due to undersampling or due to low frequency sampling, we are getting this aliasing. Then the undersampling results in loss of information of the picture. What happens if low frequency rate is used? Then we may lose the information in the picture. It occurs when the sampling is done at a frequency lower than Nyquist sampling rate or Nyquist sampling frequency. So all of you must be knowing about the Nyquist sampling rate. It is nothing but the frequency is considered as f, and the sampling frequency fs should be equal to 2 into f max. So if this is done, then there will not be any aliasing effect. So here is the formula, that is nothing but the maximum frequency into 2. If that is considered as the sampling rate, then that will never be a low sampling rate, or the undersampling will not be caused. And as undersampling is not there, that means aliasing will be also not there. So to avoid the loss, we need to have our sampling frequency at least twice that of highest frequency. So that is called as Nyquist sampling frequency. So maximum frequency G असेल 2 into that maximum frequency एवढी जर आपण sampling frequency ठेवली, which is your Nyquist sampling frequency Fs, तेवढी जर frequency ठेवली तर we will not get any distortion in the line. The staircase effect किंवा aliasing effect line मध्ये आपल्याला नाही येणार. So that is one outcome or one method to remove this aliasing effect. Okay. Next is, this can be also stated as that our sampling interval should be no longer than half the cycle interval. Okay, you know the relation between the frequency and time. What is the relation between frequency and time? Inversely proportional, right? So we can say that T is equal to 1 by F and all. So we can have the time also. So here it can be stated that the interval should be no larger than half. So obviously, if we are multiplying here by 2, then in time domain, we have to divide it by 2, right? And that is why it is said that the interval, the sampling interval, that is the time interval, should not be larger than half of the cycle interval. So here we have to divide it with 2. This maximum required, the sampling interval is called as, this maximum required is called as Nyquist sampling interval. म्हणजे ही आधीची frequency जी होती त्याला Nyquist frequency असं म्हणतात. So we are going to call it as Nyquist frequency, which is 2 into F max, or it is also called as Nyquist interval, which is nothing but the total cycle divided by 2. So it is the interval of the cycle, that is the difference between the two time domain. The next is, so that is how we can remove the aliasing. If we are using the Nyquist rate of sampling, that is Nyquist rate of frequency, Fs is equal to 2 into maximum frequency. If that is done, then we can remove the aliasing, or there are some more techniques to remove this aliasing effect. That is called as methods of anti-aliasing. AA stands for anti-aliasing. Okay, so we can go for this method of using Nyquist frequency, Nyquist interval, or we can make use of these techniques. So what are those techniques? First technique is we can use high resolution. We can use high resolution. So what do you think, whether using high resolution will reduce this staircase effect? Okay, so let us draw the diagram, then you will understand. Okay, so we will learn first the methods. So here are the methods of anti-aliasing, that is how to remove this staircase effect or jags from our picture. It is done either by using the high resolution display. So first method is to use high resolution display. Second is use super sampling, or it is also called as post filtering. You can use the super sampling methods, or it is also called as post filtering methods. Then you can use the pre-filtering methods, or it is also called as area sampling. So super sampling or area sampling. And next is pixel phasing. So you are having these 4 methods to reduce the aliasing effect. Okay, so let us see the first method using high resolution display. One way to reduce aliasing effect and increase sampling rate is to simply display object at a higher resolution. Using high resolution, the jaggeds become so small that they become indistinguishable by the human eye. Hence, jagged edges get blurred out and edges appear smooth. So let us see the meaning of it. Okay, so what they are saying, if we want to reduce the aliasing effect, we have to and increase the sampling rate. जर sampling rate वाढवायचा असेल and aliasing effect कमी करायचा असेल, then we can use the display of high resolution. So what is resolution first of all? What is resolution? Yes, what is the meaning of resolution? पहिला chapter आपण केलेला होता. Resolution म्हणजे काय? Screen resolution. Okay, whether my voice is breaking? Or it is clear?
It was breaking, and now it's clear.
Okay, okay. So resolution means what? The number of pixels on the screen. Number of horizontal pixels into number of vertical pixels. That is your screen resolution. किती pixels screen वरती है? समजा if currently I am having 100 pixels on the screen. If currently the screen resolution is 100 pixels. Now, if I am going to increase the resolution, I will increase the resolution into 4 times. म्हणजे आता currently काय black box जे आहेत ते दाखवते screen resolution 100 आहे. And I am going to increase it 4 times. I will make it 400. So what will happen now? Just keep an eye over here. एक स्क्रीनचा जो पिक्सेल आहे, that I am going to divide it into 4 parts. Okay, that I am going to divide it into 4 times. So what will happen now? If I want to draw a line, you can see okay, so you can see here the jaggeds are reduced. Okay, so earlier I used to get the jaggeds with a larger staircase width. ही जी width होती ती तुम्हाला जास्त मोठी मिळत होती का तर रिझोल्यूशन कमी होतं, रिझोल्यूशन 100च होतं. आता काय होतंय, आता मिळणारी जी width आहे ती तुम्ही ऑब्झर्व करा. मिळणारी जी width आहे ती तुमची किती झालेली आहे, हाफच झाली ऑलमोस्ट. Right? So whenever I am increasing the resolution, you are going to reduce this staircase effect किंवा aliasing जे आहे ते कशामुळे होतंय? तर see here, using the high resolution, the jaggeds become so small. आता काय झालंय, हे jaggeds जे होते ज्याची width होती ती आता कमी झाली आहे. So if further I will use instead of 400, if I am again subdividing it and using the screen with high resolution, then again those jaggeds will become so small that they become indistinguishable, की ते एकमेकांपासून वेगळे ओळखूच येणार नाही to the human eye. Hence, the jagged edges get blurred out and edges appear smooth, so that these staircase will not be observed by the human eye and they will look like a smooth edges only. So staircase effect will be completely eliminated if I am using the high resolution display. Getting it, all of you? Okay. So its practical application where we are using this type of techniques is the practical application. For example, retina displays in Apple device, comma, OLED display have high pixel density due to which jaggeds formed are so small they are blurred and indistinguishable by human eyes. So it is the practical use is in Apple devices where the resolution is so large that we are not able to view those jaggeds in the display. Okay. Right. So that is the first method of anti-aliasing, which is called as use of high resolution display. Then second method is post filtering, or it is also called as super sampling. So in this method, we are increasing the sampling resolution by treating the screen as if it is made up of much more fine grid, due to which the effective pixel size is reduced, but the screen resolution remains the same. Now, the intensity from each subpixel is calculated and average intensity of the pixel is found from the average of the intensities of subpixels. Thus, we do sampling at higher resolution and display the image at lower resolution. So here, actually the resolution is not going to change. But what will happen? See here. Okay. So this particular line, if I observe this particular line, so it is a slanted line. So I can say along this path, along the slanted path, the intensity is more. The intensity is more, and the sides of it, and along the sides, I don't have gray color, but you have to assume that this is gray. Oh, it will not be visible. Okay. So along this line, it is having the highest intensity, and along the pixels near, it is of less frequent, it is of less intensity. So it is observed like a straight line with maximum intensity, and the outside portion is having the less intensity. So what we are going to do is, now if I consider this one pixel, if I consider this one pixel while drawing the line, then actually I am not increasing the resolution, but I am going to sample it in such a way that it has increased its resolution. How? So here I am going to give color accordingly. So I am going to color the pixels which are on the straight line. They will be of line color. स्ट्रेट लाईनचे जे पिक्सेल असतील त्यांना आपण लाईनची इंटेन्सिटी प्रोव्हाइड करणार आहोत आणि त्याच्या कडेचे जे पिक्सेल असतील त्यांना आपण लाईट इंटेन्सिटी देणार आहोत, मे बी ग्रे कलर. Okay, consider this background color is gray color only. So what we are doing, we are not actually changing the resolution of this, but we are sampling it in such a way that the subpixels are having the average intensity. म्हणजे आपण काय करणार आहे, याची इंटेन्सिटी चेंज करणार आहे आणि along this straight line they will be of having the maximum intensity, and along the sub portion where these jaggies are appearing, there they will have low intensity as if they are removed. And that is why here we are actually sampling it with the multiple pixels, or it is acting as a super sampling, but actually we are not changing the resolution. So we can have this reading once again so that it will be clear to you. In this method we are increasing the sampling resolution. फक्त आपण काय करतोय, सॅम्पलिंगचं रिझोल्युशन वाढवतोय, स्क्रीनचं रिझोल्युशन चेंज करत नाहीये. By treating the screen as if it is made up of much more fine grid, as if it is much more फाईन ग्रीड, म्हणजे त्याच्यामधले नंबर ऑफ पिक्सेल्स जास्त आहेत असं ट्रीट करतोय. ड्यू टू विच द इफेक्टिव्ह पिक्सेल साइज इज रिड्युस्ड. मग इफेक्टिव्ह पिक्सेल साइज इज गेटिंग रिड्युस्ड, but the screen resolution remains the same. Now the intensity from each subpixel is calculated. Now these are the 4 subpixels. You have to calculate the intensity of them, and as per the intensity you are going to assign the values. So the intensity now the intensity from each subpixel is calculated, and average intensity is found from the average of intensities of subpixels. So you are going to assign the intensity for that pixel which is based on this subpixel intensity. Thus we do sampling at high resolution. Means we are going to do the sampling at high resolution and display the image. One second. Yes, and actually we are sampling at high resolution and display the image at lower resolution. So we are going to sample it as if it is having the high resolution, and at the time of display we are using the low resolution. That means actually we are not increasing the resolution, and this technique is called as super sampling. Okay, and this also is giving you less staircase effect. It is also known as post filtration. Okay. So what is the practical application of it? In gaming we are using this method, that is super sampling anti-aliasing, that is SSAA, super sample anti-aliasing, or full scene anti-aliasing, FSAA. It is used to create best image quality in gaming. It is often called the pure AA, and hence it is very slow and has a very high computational cost, right? Because every time we are going to subdivide it, but at the time of printing the picture we are going to combine them, and that is what it requires high computational cost. Every time more computation is required to subdivide it, to perform the sampling at high resolution and display the image at low resolution. So it has high computational cost, and it is also very slow because the time is required for computation. This technique was widely used in early days when better AA techniques were not available. So different modes of SSAA are 2x, 4x, 8x, etc. That means 2 times you are increasing the resolution, 4 times you are increasing the resolution, and 8 times you are increasing the resolution. So X denotes the times, how many times more you are going to do than current resolution. Okay. So that is the gaming application of super sampling. Then a better style of AA is MSAA, that is multi-sampling anti-aliasing, which is faster and approximate style of super sampling AA. So this multi-sampling anti-aliasing technique is working same as that of super sampling, but the rate of the implementation rate is higher. It has lesser computational cost. Better and sophisticated super sampling techniques are developed by graphics card companies like CSAA by NVIDIA and CFAA by AMD. So these are the graphics card manufacturers, NVIDIA and AMD, and they are using these techniques for getting read from the aliasing effect. So these are the practical applications of super sampling, or it is also called as post filtering. Getting this, all of you? First two methods. First is using high resolution, and second is by using super sampling or post filtering. Getting it?
Yes, ma'am.
Okay. Girls, all of you getting it?
Yes, ma'am.
Okay. So the next method is pre-filtering. So we have seen the post filtering. Now we are going to pre-filter, or it is also called as area sampling. So in area sampling, pixel intensities are calculated proportional to the area of overlap of each pixel with objects to be displayed. Here, pixel color is computed based on the overlap of seen object with the pixel area. Okay. What is this pre-filtering is? Pre-filtering calculates the area which is overlapped by the picture. Okay. So consider okay. So consider this triangle. Now what this pre-filtering does, it calculates the intensities which is proportional to the area covered by the object. Now look at this pixel. I will denote it with white color. So look at this pixel. So half of this pixel is inside the triangle and half is outside. That means it has the 50% overlapping of the object in the pixels area. So it calculates the intensity accordingly. So it has, it will consider the 50% intensity of that pixel. So suppose this intensity is 100% blue color is there, then it will fade that color up to 50%. So it is showing that the intensity is dependent upon the area which is overlapped by the object in that particular pixel. So it is stated over here. Now you consider this pixel. Where only small portion is outside, remaining portion almost 95% of the pixel is overlapped. So it will have the intensity accordingly for that particular pixel. So it will be more blue as compared to this particular pixel. So almost the border pixels are there, they will have the less intensity, and the inside pixels are having the maximum intensity. So this is done in case of area sampling. It is based on the area of the overlapping of the picture with respect to the pixel. Okay. And that is called as area sampling or pre-filtering. So you can read it again and the things will be clear to you. So in area sampling, pixel intensities are calculated proportional to the areas of overlap of each pixel with object to be displayed. Here pixel color is computed based on the overlap of the scene object with the pixel area. So here 50% overlapping, here 95% overlapping. Okay. Suppose a line passes through 2 pixels. The pixel covering bigger portion, 90% of line displays 90% intensity, while less area, that is 10% covering pixel, displays 10 to 15% of intensity. Right. So we have seen the same thing here. If pixel area overlap with different color areas, then the final pixel color is taken as average of the colors of the overlap area. So if multiple colors are introduced here, then we are going to take the average of those intensities. This method is also known as pre-filtering, as the procedure is done before generating the rasterized image. Pre-filtering का म्हणतात त्याला? Because this all calculations, pixel-wise calculations are done before actual display of that image. And that's why it is called as pre-filtering. This method is also known as pre-filtering, as the procedure is done before generating the rasterized image. It is done using some graphics primitive algorithm. So there are some algorithms to perform this pre-filtering. Okay, so these are 3 methods. The fourth method is pixel phasing. It is a technique to remove the aliasing. Here the pixel positions are shifted to nearly approximate positions near the object geometry. Some systems allow the size of individual pixel to be adjusted for distributing intensities, which is helpful in pixel phasing. So here what is done? Here we are going to adjust the pixels. Like here only some portion of the pixel is outside. So we are going to adjust the whole pixel inside this area. And that particular thing is done in pixel phasing. So it removes this aliasing and pixel positions are shifted to nearly approximate positions. If I am having this particular pixel for consideration, the top pixel, then only small portion of the picture is appearing here in this pixel. So we are going to remove that particular portion, and we are going to assign the whole pixel is with background color only, right? So that is called as pixel phasing. So we are going to change the position, or we are going to change the pixel to its approximated positions. and those pixels are adjusted in the pixel phasing. Getting it? So that ultimately we are going to remove the aliasing effect. Okay, is that clear to you? Yes. Yes, students.
Yes, ma'am.
Okay. Okay. So what are the different applications of anti-aliasing techniques? So just now we have seen what is aliasing, then how to remove those aliasing effect using anti-aliasing method. So 4 methods we have seen: resolution improvement, then post filtering, pre-filtering, and phasing, pixel phasing. So these are the 4 techniques, and now we are going to see the applications of anti-aliasing techniques. So 2 main applications. First is compensating for line intensity differences. So when the horizontal line and a diagonal line plotted on the raster display, number of pixels required to display both the lines is same, even though the diagonal line is 1.414 times larger than the horizontal line. Whether you have observed this thing while drawing the lines on the at the time of practicals. Okay, इथे आपण काढून बघूया. ही किती पिक्सेलची लाईन आहे? 1 2 3 4 5 6 पिक्सेल्सची आहे. If I want to draw the 6 pixels line, इथून चालू करते 1 2 3 4 5 6. See here. ही horizontal line आहे which is composed of 6 pixels आणि ही slanted line आहे which is composed of 6 pixels. कोणती लाईन मोठी दिसतेय तुम्हाला? Obviously ही slanted line मोठी दिसतेय ना. इथं हा 6
Yes, ma'am.
Yes, and that proportion is 1.4 point, म्हणजे दीडपट जास्त almost. So 1.5 times more larger दिसते, जरी ही पण 6 पिक्सेलची आणि ही पण 6 पिक्सेलची लाईन आहे. Okay, so we are going to have this compensation of this horizontal line and slanted line over here. So we will read it again. When a horizontal line and diagonal line are plotted on the raster display, the number of pixels required to display is same. 6 pixels दोन्हीकडे लागले. Even though the diagonal line is this time 1.414 times larger than the horizontal line. This leads to decrease in the intensity of longer line. What happens? This leads to decrease in the intensity. मग तुम्ही आता बघताय की ही लाईन जास्त डार्क दिसतीये तुम्हाला, ब्लॅक. हॉरिझॉन्टल आहे, ही जास्त डार्क दिसतीये, पण ही तेवढी इंटेन्सिटी जास्त दिसतीये का तुम्हाला? नाही. सो इट लीड्स टू डिक्रीज इन द इंटेन्सिटी. ही डायगोनल लाईन आहे, त्याच्यामध्ये intensity of the pixels will be less. The intensity of pixel is assigned according to the length of the line using anti-aliasing techniques. So we are using here the anti-aliasing techniques to decide the intensity of the pixels of the line. So that is nothing but your advantage, or we can say application of this anti-aliasing method. So due to that increased length, the intensity is getting reduced, and with anti-aliasing methods we can decide the intensity of pixels in the slanted line. So that is application. The second application is anti-aliasing area boundaries. So Anti-aliasing concept can also be applied to remove the jaggies along area boundaries. These procedures can be applied to scanline algorithms to smoothen out area boundaries. So the same techniques of anti-aliasing are used to smooth the boundaries of the polygons. So in the scanline algorithms, if repositioning of pixel is possible, then pixel positions are adjusted to positions close to the area boundaries. So here pixel phasing plays an important role. So if we want to adjust the pixels, then we can shift those pixels near the boundaries to remove that jagging effect. Then other method adjust pixel intensity at boundary positions. So which method uses the intensity calculation? We know the adjustment of the position is done in pixel phasing, and the intensity calculation is done in post filtering method. Here the intensity calculation, right? So both are used to decide the boundaries, either pixel phasing or pixel or post filtering. So they are used to decide the boundaries. Okay. So other method adjust the pixel intensity at a boundary position according to the percent of pixel area inside the boundary. This method effectively smoothen out area boundaries. So here pre-filtering is also used. So to smooth out the boundaries of the polygon, we can make use of pixel phasing as well as pre and post filtering intensity manipulation. Okay, so these are the advantages. First is to decide the intensities of the slanted line and to decide the boundaries of the polygons. We use these anti-aliasing methods. Okay, and the next technique we are going to make use is half toning. So half toning is the method mainly used in case of newspapers and all. So it makes use of variable intensities to show the or to represent the image. So that we will see next. Yes, half toning. So half toning is one of the method which uses okay, so here what we were doing in this examples, we are adjusting the intensities of the pixels. We are actually adjusting the intensities of the pixels. So those intensities are ranging from 0 to 255. So total 256 is the range where 0 to 255 number of intensities we can access. But here in half toning, we are going to use only grayscales. Grayscales means only black and white and mixture of them. So we are going to use only two colors in half toning. So that is the difference between anti-aliasing and half toning. Anti-aliasing uses multiple colors for intensity calculation, but half toning uses only two colors, white and black. And this mainly used in case of newspaper printing. So let us see what is half toning method. So newspaper photographs simulate a grayscale despite the fact that they have been printed using only black ink. आपण न्यूजपेपर मध्ये ब्लॅक अँड व्हाईट पिक्चर बघतो, पण ऍक्च्युली त्याच्यामध्ये व्हाईट इंक यूज केलेली नसते, त्याच्यामध्ये फक्त ब्लॅकच इंक यूज केलेली असते, तरी पण आपल्याला शेडेड इफेक्ट दिसतो त्याच्यामध्ये. बरोबर, आपल्याला त्या न्यूजपेपर मध्ये शेडिंग इफेक्ट दिसतो. Why? Because the pixels are arranged in such a way that it will show the grayscale. म्हणजे फक्त ब्लॅक यूज करून सुद्धा तुम्हाला व्हाईट पासून ते ब्लॅक पर्यंतचे सगळे पॉसिबल कॉम्बिनेशन्स तुम्हाला बघायला मिळतात हाफ टोनिंग मध्ये. सो वी आर ऍडजस्टिंग द पिक्सेल्स in such a way that we are adjusting the pixels in such a way that instead of displaying only black color, we are able to view the complete range right from white up to black. मग मधल्या ग्रे कलरचे सगळे तुम्हाला कलर कॉम्बिनेशन किंवा शेड्स बघायला मिळतील न्यूजपेपर मध्ये. देन हाऊ इट इज डन. So here we are going to have the variety of sizes of dots. We are going to make use of variety of sizes of the dots in the newspaper. So let us read the information. So newspaper photographs simulate. So actually only one black ink is used, but it simulates a complete grayscale. All the gray color shades are available here, despite the fact that they have been printed using only black ink. Actually fact काय की फक्त black ink use करून आपण newspaper print करत असतो, but they show all the gray scales, all the gray shades. A newspaper picture is in fact made up of pattern of tiny black dots of varying size. So in this pattern, we are using the tiny black dots of variety of sizes. The human visual system has a tendency to average brightness over small areas. Now how we observe? We are observing that we are observing the small area and we are going to average the brightness of those small areas. It is the tendency of human vision. So black dots and their white background merge and perceived as intermediate shade of gray. Backside ची background जी white आहे आणि black color चे जे dots आहेत, they together will form a gray shade. Right? They together will intermediate shade of gray it will form. The process of generating a binary pattern of black and white dots from an image is termed as halftoning. So in halftoning, only two colors, black and white, are used, and they are pretending to have multiple shades in gray. In traditional newspaper and magazine production, this process is carried out photographically by projection of transparency through a halftone screen onto film. So earlier this process of representation is done with a projection of a transparency in photographic skill. Okay, then the screen is a glass plate with grid etched on it. That screen is a glass plate with a grid etched on it. So what is the meaning of it? So consider this is a glass plate and it has a grid on it, that is the larger black dots followed by somewhat smaller dots, which is again followed by again smaller dots. So the size of dots are getting reduced. So this is here a glass plate, and using this glass plate we were able to draw the pixels. Okay, so you can observe here the size is getting reduced. Okay, so this is the glass plate which is having a grid etched on it. So it is having the grid etched on it. The different screens can be used to control the sizes and shape of the dots. So such number of plates we can use to control the size and shape of these dots. A fine grid with a screen frequency of 200 to 300 lines per inch gives the image quality necessary for magazine production. So every production or every newspaper or magazine, and they will have the differential patterns. प्रत्येक न्यूजपेपरचा किंवा मॅगझिनचा एक वेगळा पॅटर्न होता, ज्याच्यामध्ये ही जी ग्लासची स्क्रीन वापरत होतो ती व्हरायटी ऑफ डॉट्सनी बनवलेली असते. मॅगझिन प्रोडक्शन साठी यूज केलेली स्क्रीन फ्रिक्वेन्सी होती ती 200 to 300 लाईन्स पर इंच होती. म्हणजे अशा लाईन्स 200 एका इंच मध्ये 200 to 300 लाईन्स असतील अशा. देन a screen frequency of 85 lines per inch is acceptable for newspaper. न्यूजपेपर साठी हीच लाईनची फ्रिक्वेन्सी काय होती 85 lines. So this method is used in case of magazines and newspapers with black and white color. So see here, the variety of dots. Dots ची साईज चेंज झाली. तुम्ही ऍक्च्युली फक्त कॉम्बिनेशन करताय ब्लॅक अँड व्हाईटच. But as the size of dot is changing, the picture quality is also changing. So here are the bigger dots present, then somewhat smaller, then very small dots. So here, then again smaller and all. So every picture is having variable size of dots present. So actually the background is white and we are printing the black dots on it. And this picture is getting the different resolution, right? So this method was used in case of printing the newspapers and magazines earlier, and it is called as halftoning. Okay, so again in the halftoning we have one more sub part which is called as patterning. So patterning is nothing but the portion or the block is divided into sub blocks. That is, one pixel is divided into 3 by 3 block or 2 by 2 block or like that, and every sub block will be given a separate pattern. So if I want to draw the alternate black and white strips, then every pattern is having, I'm going to make use of different patterns. Suppose here are the 9 patterns available and I want to draw the rectangle, or I want to display the rectangle. So I may be using this portion followed by this portion followed by the rotation of this again and so on. So I'm going to make use of 6 number pattern and its rotation so that I can get the complete rectangle or maybe square or anything like that. So it is giving me the patterns for a 3 by 3 block. So that is called as patterning. So in patterning, you have the simple digital halftoning technique, which is involving the replacing each pixel in a binary font. So here you are going to make use of 2 colors only, and that's why it is called as binary font. We show such a font made up of 3 by 3 matrices of a pixel. So we are going to make use of 3 by 3 matrix. This font can be used to print image consistency of 10 gray levels. So here 10 gray levels are there, 0 to 9. The total white color, 1 black, then 2 black, then 3 black, then 4 blacks, 5 black pixels, 6 blacks, till all black pixels. So total 10 different levels are, or 10 gray levels can be printed by using this patterning method. So this is the example of patterning, where a pixel with gray level 0 is replaced by the matrix containing no white pixels. A pixel with gray level 1 is replaced by the matrix containing single white pixel, and so on. So the pixel where the white is there, then it is replaced by 0. That means earlier this pixel. White color is represented with 9 color block. Black color is represented with 0, this block. And if I want to use 1 black, then I will be using 8 number pixel over there. So the portions which will give you the more clear view, that is 1 pixel is divided into 9 sub blocks. So ultimately the resolution is greater and you are going to get the great resolution out of that. So see here. Note that since we are replacing each pixel by 3 by 3 block of the pixel, both the width and the height is increased by factor 3. That means the resolution is going to increase. Figure 5.2, that is this figure, shows an example of halftoning using the binary font depicted in the 5.1. So this is the 8-bit image and we are going to use the halftone image over here. So here we are using the 8 bits, but here we are going to make use of only 2 colors, white and black. Then also due to higher resolution, we are getting moderately good quality of the picture. Then along with patterning, we are having one more method which is called as dithering. So dithering is nothing but we are going to halftone the color images. See here, the whole picture is consisting of yellow and red small blocks. If I am going to zoom this out, then ultimately I am going to get the alternate blocks or checks pattern of red and yellow. But all together I am going to observe, then I will be getting orange color out of that. जर मी झूम करून बघितलं तर मला जवळून हे चेक्स दिसतात, पण या पिक्चर मध्ये तुम्हाला काय दिसतंय, हे कंबाईन इफेक्ट देते ह्यूमन विजनला, which is showing you orange color, right? So it apparently orange, actually red and yellow, actual red and yellow, but it looks like orange. That is done in case of dithering. So in dithering, the matrices are used. So here, if the dither 1 matrix is 0, 128, 192, and 64, if this is the first dither matrix, then addition of some value in the we are going to add the same value in those 4 elements. See here, 0 मध्ये आपण 32 ऍड केलेलं आहे, सो 128 मध्ये पण 32 ऍड केल्यानंतर 192 मध्ये पण 32 ऍड केल्यानंतर तुम्हाला हा मॅट्रिक्स मिळतो. सो व्हॉट वी आर डुईंग, वी आर युजिंग द सेम मॅट्रिक्स 2 by 2, बट बाय ऍडिंग सम अमाउंट. सो हियर 32 ऍड केलेत या 4 एलिमेंट मध्ये, इथे 48 ऍड केलेले आहेत आणि इथे 16 ऍड केलेले आहेत. So I am going to represent the same dither, same matrix 4 times. So it is giving me like a thresholding of this matrix with some value. So dithering can be accomplished by thresholding the image against a dither matrix. So we are going to threshold this image with this dither matrix. The first 2 dither matrix rescaled for application to 8-bit images are, so you can have these 2 matrices D1 and D2 that together will give you the third matrix, which will be giving the 8-bit image. Here 4 by 4 into 2 by 2, so total you will be getting the 8 by 8, that is 8-bit images as an output. So that is done in case of halftoning. So halftoning has 2 sub patterns or sub parts. One is patterning and other is dithering. So in dithering, the elements are thresholded. The matrix is laid like a tile over the entire image, and each pixel value is compared with the corresponding threshold from the matrix. The pixel become white if its value exceed the threshold or black otherwise. So here in halftoning only 2 colors are there, and that's why we are going to make use of dithering to show either white color or black color. So if threshold value If we are going to get more than threshold value, then the pixel becomes white. And if less than threshold value, then the pixel becomes black. So this approach produces an output image with the same dimensions as the input image, but it is the details are less visible. Right. So this is the sub part of your half toning. Okay, so dithering and patterning is not there actually in your syllabus. Up to half toning you have in your syllabus, but as they are the content beyond syllabus, I have covered these two subparts also in half toning. So up to this particular slide, half toning, and this slide you have in your syllabus. Okay, so this ends with your chapter number 5. And we are using this methods of anti-aliasing and half toning to make the picture more clear, and which is aliasing free. Okay, is there any difficulty?
No, ma'am.
Okay, so we will stop here. Already the time is up, 7 minutes. I have taken more. Okay, so we will stop here. Thank you. And the revision part of chapter number 6 that we will see in the next lecture. Thank you. You can leave the meeting now.